In dealing with infinite geometric series problem, this formula is being used. S sub infinity is equal to A sub 1 over 1 minus R, where S sub infinity is the sum of the terms, A sub 1 is the first term, R is the common ratio, but R must be less than 1 and more than negative 1. So let us take this given example number 1. Find the sum of the given geometric sequence 2, negative 6, 18, and so on. Before we write down the given, let us examine first our common ratio. So to solve for the common ratio of this given geometric sequence, so negative 6, that is the second term, divided by its preceding term, which is 2, and our common ratio is negative 3. Since negative 3 is beyond the range of our common ratio here, so it means this geometric sequence diverges. This tells us that the geometric sequence approaching to infinity. Therefore, this infinite geometric sequence doesn't have sum. The sum does not exist. In our given number 2, find the sum of the given geometric sequence 1, 7, 49, and so on. So let's start examining the common ratio. So the second term is 7 divided by its preceding term, which is 1, and that is 7. So since 7 is also beyond the range, therefore, so this geometric sequence diverges and the sum does not exist. In our given number 3, find the sum of the geometric sequence 10, 1, 1/10, 1 over 100, and so on. So if we're going to find the ratio in this given, that is the second term 1 divided by the preceding term 10. So our ratio here is 1/10 or 0.1 in decimal. Notice that 0.1 is within the range. So it means this geometric sequence converges. We can find the sum, or the sum does exist. So we can now continue finding the sum of this infinite geometric sequence. Since our R, or common ratio, is 1 over 10, our A sub 1 is 10. So we can now find the S sub infinity. So to solve this, write the formula, substitute the given. Then A sub 1 is 10, R is 1/10. So we'll just simply rename 1 into 10 over 10 in order to subtract our given easily. So from here, 10 minus 1 is 9. Then copy the common denominator 10. Then just simply copy this 10. Then we have here 10 divided by 9/10. So we can rewrite this like this. And we know that 10 has a denominator of 1. So to divide these fractions, we'll just change division into multiplication and get the reciprocal of 9/10 into 10 over 9. Then just simply multiply numerator by numerator. 10 times 10 is 100. 1 times 9 is 9. Or you can actually cross multiply this. 10 times 10, that is 100. 1 times 9, that is 9. So this will be our answer. We can also write our answer in decimal form. 11.1111, or just simply 1, then bar on top of the decimal, which indicates that this decimal 0.1 is repeating. And this is our answer. In our example number 4, find the sum of the given geometric sequence 8, 2, 1/2, and so on. So our ratio here, or common ratio, is 2 over 8. So that is 0.25. So since 0.25 is within the range, so our geometric or infinite geometric sequence converges. So we can find the sum. Our ratio here is 2:8. So if we're going to simplify this, that is 1/4. Our A sub 1 is the first term, 8. So write the formula, substitute the given. So our A sub 1 is 8, our R is 1/4. So we want to rename this 1 into 4 over 4. So our purpose is so that we can easily subtract 1/4 to our 1. 4 minus 1, that is 3. Then copy the common denominator 4. So copy also this 8 right here. Then we will rewrite this 8 divided by 3/4 into this way. Then change division into multiplication and get the reciprocal of 3/4, and that is 4/3. Then 8 times 4 is 32. 1 times 3 is 3. So this is our answer, 32 over 3, or we can also rewrite this in decimal form, 10.6 bar, or 10.66666.